Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Space Invaders by Michael Lefkowitz. And I'm doing this because it's sort of nostalgia. I vaguely remember having an Atari way back when as a kid, um, and playing this. I was never very good at it, but it was always kind of cool. So this sort of brings back memories. Um, Anyways, what are the rules? We have normal Sudoku rules apply, which means in every cell in the 9 by 9 grid, place a single digit from 1 through 9 such that every row such that there are no repeats in any row, column, or box in the 9 by 9 grid. We have invaders, where each invader sums to 10 with a digit in some orthogonally adjacent cell. So for example, this must sum to 10 with one of the cells that it shares an edge with one of these four cells, right? So this invader, ooh, that's pink, must sum up to 10 with one of these cells because those are the cells that it shares an edge with. And that's how invaders work. We have difference bombs, where digits connected by these bomb-like things always have the same difference, but we don't know what the difference is. So say that the difference was 3. Then if this were a 6, this would have to be 3 or 9, because the difference between the digits connected by these difference bombs must have the same difference, and we have to figure out what that difference is. Turrets. Strategically place 3 turrets into cells in the bottom row. So we have to place turrets in these cells. Each turret has as many missiles as the digit in its cell and can pivot to fire them upwards or diagonally. A turret can destroy an invader on a digit n by shooting it n times. Okay, so an invader will have a digit on it, and it must be able to be shot n times to destroy it. And all invaders must be destroyed. Okay, so then obviously you can shoot up, you can shoot diagonally, and that's it. But there's also limited ammunition, right? So each turret we can place three turrets, that's it. And they are all in the bottom row, and we are limited to the number of the turret can only fire as many bullets as the digit that it contains, right? And it can only shoot vertically or vertically diagonally. So we have to be able to kill off all the invaders or destroy all the invaders by these 3 turrets. And on top of that, the invaders can only be shot or can only be destroyed by shooting it however many times its digit is. So for example, say this, oh yeah, we should give an example of the invaders. So say this was a 3, and this would guarantee 7 has to be one of the cells that shares an edge with it. But to destroy this invader, you have to shoot it 3 times, or be able to shoot it 3 times, in essence. Interesting. Those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we only have 24 shots in the tourists at most because we only have 3 in the bottom row available. You are guaranteed in each row and column a certain number of possibilities. So this is at minimum 1 through 4, which is 10. This is at minimum 1 through 3, which is 6. So we have 10, 6, 16. This is at minimum 3, and this is at minimum 3. So 16 plus 3 is 19, plus 3 is 22, plus 1 and 1 at minimum is 24. So all 24 shots must be hit. So therefore, this has to be 1. This is 1. This has to be a 1-2 pair. This cannot be 1 because of the 1 in the box. So that's 2, which makes that 1. This can't be 1, so that's 2 and 1. We need 1 and 1 of these. So this has to be, again, 1, 2, 3, 4. And this is 1, 2, 3. 1 cannot be here. 1 cannot be here. These can't be 2. This 1 eliminates 1 here. We have a 1, 2, 3, 4 quadruplet in box 5. So that means we have to guarantee a 4 here because the rest of the box cannot contain 1 through 4. So that means this cannot be 4 here. We have a 1, 3 pair in box 8, which eliminates 1 and 3 in the rest of the box. This can't be 3, that's 2, which eliminates 2 here. Okay, where can these be shot by is kind of the question. You can shoot along this diagonal. Yeah, let's look at diagonals. This cannot be shot by a diagonal there, but it could be shot by a diagonal there. Okay. So this is a very attractive possibility here, because it shoots along a pretty wide diagonal here. This only hits one thing on the diagonal, so it's very unlikely that this is going to be a shooter. This hits 2, 3. So this, let's see how many things that it hits on the diagonal. I guess let's just start coloring. So this will hit, okay. This will hit these cells. And this one. I guess we'll make this yellow. That hits this cell and this one. Makes this red. That hits these cells here. So those red. We'll make this orange. Orange hits all of these, which is great. It does not hit anything here. It hits these two. Pink hits just those two. I think that's it. We have green. Green hits those 3, which is good. And then these 2, which is good. Okay, dark does not hit anything here, does not hit anything here, and just hits one thing here. So it hits that. Medium hits these 2. And these 2. That's not bad. And light, we can't even see. Light hits everything there, but just nothing. And it just hits one thing here. So light just hits that. So light only hits, okay, so light hits 1. So that we can probably discount. So let's just remove that. Dark hits or medium hits 4. That seems okay-ish. Dark hits 1? 1? Yeah, just 1. So that's out. That's just too few. Green hits 1, 2, 3, 4, 5. That's pretty likely. Pink hits only 2. So that's out. There's just too many invaders here, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 invaders. And 2 is just not going to cut it. You have to have 5 and 6. Let's just leave it there for now, I guess. So 2. Orange hits 1, 2, 3, 4, 5, 6. So it could actually be pink. Okay. 1, 2, 3, 4, 5, 6. Red hits 1, 2, 3, 4, 5. And remember, there's also some overlap. Okay, so that's also another thing. Yellow hits 1 and 2. And then blue hits 5. Okay, this is only hit by red. So we're guaranteed that this has to be 1. Okay. So red can cover all of these. That's interesting. So we are guaranteed red has to be one of them. So red is guaranteed to be one of the shooters. To have 2 and 6. So for either of the 2s to work, it has to be with the 6 because there are 13 invaders. So we have to be able to hit all 13 to destroy them. So with the 6, that means orange is here. And these require blue or green. So we are guaranteed then yellow and pink don't work. But you could have 4, 5, and 5 potentially. So yellow and pink don't work, so let's clear those. And pink doesn't work. So we can clear those. We are guaranteed orange. What happens? So we need 1 out of blue or green here. So we're guaranteed red. We need 1 out of blue or green, definitely. But red is all covered here. Can we do gray with green or blue is the question. Gray would force these. That seems okay. But this requires orange or green, and this requires orange or blue. Which means if we only had green, this would not be covered. If we had only blue with the gray, this would not be covered. So therefore, you cannot use pink. You can't have only gray. So gray does not work, which means we can remove gray from being here, and gray from being here, and then gray from being here. Which means we require orange, blue, and red. So it has to be orange, blue, and red. Green does not count. So we can remove all the greens. And these are what are these? These are can be hit by. Okay. Obviously orange cannot hit all of these. Oh, these are hit both by orange. Okay. So we know these are the shots. These can only be hit by orange. Which means this is shooting once, this is hitting 4 times, and it's at least another 3. So this is 8 or 9 here. Red, blue is being, it has to hit this once. Oh, the problem, okay, so this is at least 8. Right? Or sorry, this is exactly 8 that it hits. We have, if this is all orange, 8 plus 1 means this can't be hit. This is only hit by red. That's interesting. This is at least 5. One has to have a 9 surrounding it for the invader. So one of these is 9, not 6. One of these is 9. Ah, which means 9 cannot be in the red or blue turret. Because to add, it needs to add up to 10 for this invader. So therefore 9 must be in the orange turret. This then has to be a 7-8 pair, which eliminates 7 and 8 in the rest of the box. And this 2 needs to add up to 10 with another digit sharing an edge. It cannot be these two because of the 7-8 pair in the box, so it has to be here. So this is 8. This 2 can't be with 8 there, so 8 has to be there. 8 eliminates 8 here, so that's 7, which makes that 8. 2 and 8 is satisfied there. So this shoots, red shoots 7 times. It has to shoot that one once. And then it could shoot some combination there. This has to add up to 10 with one of these digits, and it cannot be these because these are all less than 5. So it has to be 7 or 9 here. And this must be with 7 or 9 here or here. We're not sure. This digit also must add up to 10. And it cannot be with these two, because they are less than 5. It cannot be with that because this can't be 2. So this must be 6, 7, or 9 here. So okay, let's mark the connections with the invaders to sum. So that's 1, this is 1. Obviously, that's 1, this is 1. We don't know which one this is. Oh, this is kind of cool. They actually have the sort of turret shots here. So we are guaranteed one of these is 1, so that one of these must be 9. This has a guaranteed 9 surrounding it. This has a guaranteed 8 surrounding it. This shoots 8 times, so we have 1, 5 guaranteed here. Remaining digits in box 5, again, are 5 through 9. Obviously, this can't be 8 because of 8 in the column. This can't be 9 because of 9 in the column. Remaining digits in column 6 are 5 through 8. This cannot be 9 because of 9 in the column, so the 9 surrounding this invader has to be one of those 3. So this cannot be 9 here because we already guaranteed have a 9 in this box. So the 9 remaining to add up to 10 to surround this invader must be one of these 2. This invader could add up with that, could add up with that. We have a 5, 6, 7. Okay, so 9 is one of these to spin next to the 1. So this cannot be 9. So that means we have a 5, 6, 7, 9 quadruplet in column 5, which eliminates 5, 6, 7, 9 in the rest of the column. So this is 1 through 4. This is 1 through 4, but it cannot be 2 or 1 or 3 because of the 1, 3 pair in the box. So this is guaranteed to be 4, which means this cannot be 4 here. This is 1, 2, or 3. So the difference has to be either 2, 3, 4, 2 through 6 as a possibility. Okay, so this is 2 and 8. 2 and 8 here. 9 cannot be here. So 9 has to be one of these 3. Remaining digits in row 9 are 1, 2, 3, 5, 6. This can't be 1 or 2, so this is 3, 5, or 6. This can't be 1, 2, 3, so this is 5 or 6, and this is 1, 2, 3, 5, 6. 1, 2, 3, 5, 6, 1, 2, 3, 5, 6, but this cannot be 1 or 2 because of 1, 2 in the column. We have a 3, 5, 6 triplet in row 9, which eliminates 3, 5, 6 in the rest of the row. So this cannot be 3, 5, 6, it's 1 or 2. Okay. Remaining digits in row 7. We have 4 through 9. And obviously this can't be 7 or 8 because of 7, 8 in the box. Oh, this 9 eliminates 9 here. So this must be 7 and 3 adding up to 10. Therefore, this is 1. It must add up with a 9, and 9 cannot be in the same box, so this must be 9 here. This eliminates 7 and 9 in the rest of row 7. So no 9, no 9 there. So this is connected here. This 1 eliminates 1. This 3 eliminates 3 here, so this is 4, which makes this not 3 or 4. This is 1. The orange has already all 9 shots taken care of. It's 1, 2, 3, 4, 5, 9. So therefore, the rest cannot be orange hit. So this must be hit by red. This must be hit by blue. This cannot be 1 here. It's 2 or 3. So this must be 1 and 9 here. This 7 eliminates 7 in the rest of the column. So this is now a 5, 6 pair in box 5, which eliminates 5 and 6 in the rest of the box. And we can't have a 9 here anymore. So this is 1, 9 here. That eliminates 9 from being here. 9 is one of these 2. This has to be 5 or 6 remaining. Remaining digits in column 4 are 4, 7, 8, or 9. Okay. Remaining digits in row. So this is 1, 2, or 3 with 5 or 6. So the difference can be at most 5 now. So this must be 4 with 6. So one of these 2 digits, oops, is not a 3, it's a 6. To add up with 4. Then we have 1, 9, that's invader, 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 invader. Remaining digits of row 8. We have 3, 4, 5, 6, 9. And this has to be 7, 3, 4, 5, 6, 7. Okay. This cannot have a difference of 6, so this cannot be 3. This has to have a difference that's the same between this and this. So it cannot be a difference of 5. It could be a difference... Huh. What are remaining digits in column 7? 3, 4, 5, 6, 9, right? And neither of these can be 9. Because they must be surrounding this. So this is either a difference of 1 to have a valid scenario. Right? So it could be 3, 4, 5, 4, 5, 6. Or it's a difference of 3. But this can never have a difference of 1. So it must be a difference of 3. Which makes this 9, 6, and 3. So this cannot be 3, 6, or 9. Which means this is the relationship there. So that means neither of these can be 9. This can't be 3, 6, or 9. So this is 4, 5. Well, we have a 4, 5, 6 triplet in box 9, which eliminates 4, 5, 6 in the rest of the box. Therefore, this is 3. This is 9. That eliminates 3 here. This must be a difference of 3, so it's 9 with 6. So we have 6 here, which makes this 5, which makes that 6, which makes that 5. 5 eliminates 5 here, so that's 4, which eliminates 4 here, so it's 5. That means these can't be 4 anymore. This becomes a 5, 6 pair, which eliminates 5 and 6 in the rest of the row, so this is 4 and 8. No 4, 5, 6 here. These must have a difference of 3. 3 doesn't work with 4, but 7 and 4 works. 8 does not work with 3 or 7, so this is 4 and 7 here, which makes this 3 and 8. This has a difference of 3, so 5 goes with 2, and 6 goes with 3, so those are the possibilities. 9 cannot be here, so 9 has to be here, which means that's the connection there. This can't be 9 because of 9 in the row. This can't be 9 because of 9 in the row. So this must be 9 here to add up to 10 with this one invader. 8 here eliminates 8 in the rest of the column. So that means we are guaranteed an 8 here, which eliminates 8 in the rest of the row. This 1 and 2 eliminate 1 and 2 here, so this is 3, which makes this 2. Therefore, that makes that 1. 2 is 3 away from 5. Which makes this 6. So then we have 4 and 6 properly connected. 9 eliminates 9 here. 5 eliminates 5 there. Okay. We have the 1-9 connection here. So we have 1, 2, 3, 4. Okay. Remaining digits in column 3. We have 1, 2, 3, 4, 5, 7, 8. None of these can be 2. None of these can be 1 because of the respective digits in the row, or in the box. This can't be 1 or 5. There's no 3 or 1 here. This can't be 5 or... Well, we don't have 6. No 3 or 4 here because of 3 or 4 in the row. No 8 here because of 8 in the row. Okay, so how many differences of 3 do we have? If this is 2, these can be 5. 3 has to be with 6, but this can't be 6, so this is not 3. 4 can be with 7, but this can't be 7 here. And 5 can be with 8, so those all work. 1 can be with 4, 3 can't be here again. 5 can be with 8, and 4 can be with 7 or 1. So those are all satisfied there. 8 cannot be here because it must be orthogonally connected to the 2. Um, hmm. Okay, the remaining digits of column 2. We have 4, 6, 7, 9. So this is 4, 6, 7, 4, 6, 7, and 4, 6, 7, 9. This cannot be 9. Where is the 9 in column 2? It has to be here. So this is 9 here. This cannot be 6 because of 6 in the row. This cannot be 7, 4 as a pair to be difference of 3 because that would eliminate all possibilities for that cell. So then we can remove 4 and 7 here. This has to be a 5 next to a 2 or an 8. That eliminates 5 from the rest of the column, so this can't be 5. Therefore, this can't be 8 here. This has to be 4 or 7 or 4 and 1. That eliminates 4 in the rest of the column and box. So no 4 here, no 4 here. This is guaranteed 5. We need an 8 to be next to the 2, so this is 8. And that invader is paired up. This digit cannot be paired with this, because if it were, the problem is that it doesn't add up to 10. 2 and 5, 3 and 2, or 3 and 5 does not add up to 10. So it must be paired with this, which means these two add up to 10. So these two can never add up to 10 here, because these two must add up to 10, and therefore this digit eliminates that from being the digit that it can be paired up to add up to 10 with. Therefore, these add up to 10, and these must add up to 10, which means this cannot be 4. This is 7 or 8. We have a 7, 8 pair in column 4, which eliminates 7 and 8 in the rest of the column. So this is 4 and 9. This has a difference of 3, so that's 5. Where is 5 in box 1? Cannot be here, cannot be here, cannot be here, so it has to be here. That eliminates 5 from being here. Where is 5 in box 2? It has to be there. Remaining digits in column 1, we have 1, 2, 3, and 6. So no 1, 2 here. This is 3 or 6. No 1 here. No 6 here, so this is 2 or 3. This can't be 1. It's 2, 3, or 6. We have a... Right, where is 1 in box 1? Cannot be here. Can't be any of these. So it has to be here. So this is 1, which makes this 4. Which eliminates 1 in the rest of the column, so that's 2, which makes this 1. 2 eliminates 2 here, so it's 5, which makes that an 8, to be 3 away from that. This can't be 8 here. 8 eliminates 8 here, so this is 7, and 3 adding up to 10. Therefore, this is 2 and 8 adding up to 10. This 7 eliminates 7 here, so it's 8. 2 eliminates 2 here, so it's 3. This can't be 2 or 3. It's 7. This can't be 7. It's 4. 3 eliminates 3 here, so it's 6, which eliminates 3 and 6 here, so it's 2. This can't be 4 or 7. It's 6, which eliminates 6 here, so it's 7. This is 3. 4 eliminates 4 here, so it's 9 and 4. This can't be 6 or 8. It's 7 because of 8 in the box and 6 in the row. That forces this to be 6 there. And the rest we probably can do with just normal Sudoku. We have 2 and 5 here. That's not satisfied. This is 2 and 8 here in row 1. 8 cannot be here because of 8 in the column. So this is 2, that's 8. Remaining digits, that means this can't be 2, so this is 5, which makes that 2. 5 eliminates 5 here, so it's 6 and 5. Let's see where does everything shoot. This orange shoots 1, 1, 3, and 4. This red shoots 2, 3, and 1. And then this blue shoots 1, 1, 2, 2. And they do some combination of 3 shots to shoot these. Remaining digits in row 2, we have 6 and 7. 6 can't be here because of 6 in the column, so that's 7, 6, which leaves 3 and 4 remaining. This can't be 3 because of 3 in the column, so that's 4 and 3, which forces this to be 4 and this to be 7. And that's a solution. Pretty cool, actually. I enjoyed this. This was a lot of fun. I felt it was pretty straightforward, so it's slightly easier than challenging, but it's not quite easy level, so I'm fine placing this as a challenging level difficulty. But it was pretty cool, actually. I don't know. Maybe it's the nostalgia of Space Invaders is affecting me, but um yeah, it's basically kind of a fun. It was a fun exercise, I should say. And all the clues were well used and well developed. So it was very I quite enjoyed this. This was a lot of fun. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.